Hello, Randy here, and today we're going to talk about the easy style stair step that I built for the Tetra Society of North America. The Tetra Society is a society that makes assistive devices for people who have disabilities. And so what I made here is a step that is 6 inches tall. I'll show you right here with the measuring tape. Well, this is 6 1/8 because of the rubber on the top and the bottom. 6 inches tall by 1 foot long by 9 inches wide. The point of this step is to allow the client that I was working for through the Tetra Society to climb in and out of the pool in her condo residence. The pool has 1 foot deep steps, which are quite significant and difficult to navigate for a person with limited mobility. And so this step allows the step to be divided into 2 effectively. She can step onto the step and then step off of it and make her way down the steps with greater ease than if she didn't have this device. I began the design process for this step by visiting the client. I went to her home and I took measurements of the stairs in her house and the stairs of the pool. I took those measurements into account when designing this piece so that it would be wide enough to get a good stable base, but not so wide that it would hang over the edge of the step. I also had to take into account the fact that since it was going into a pool, it should only be made out of materials which are waterproof and corrosion proof, which limited me to galvanized steel and plastics, essentially. Another consideration in the design is in how the client wanted to carry the device. She wanted to carry the device via a cane. This cane would place the step in front of her as though it were a quad cane or similar apparatus, but the step itself could then be walked upon. The step also had to be non-buoyant, which means that I used high-density polyethylene, a non-buoyant plastic, and steel supports, which are also non-buoyant. If I had used anything else, the design would not have worked. The specifications also mandated that there could not be any trapped air, because that would also cause issues with buoyancy and instability when placed in water. And so, the end result is an open design in which water can easily pass through, water and air can easily pass through, and yet it's still very rigid and quite strong, that can be carried by a cane and is made out of materials that are durable. The 3D model allowed me to work out my sketches in a 3-dimensional space, allowing me to get a better image of how the final assembly would look. A notable change from the original design is the absence of this 8th column. When I sourced the HDPE plastic, I found a good source, a cheap source, to be plastic cutting boards. Plastic cutting boards that had handles in the top. Those handles were right in the place of where this column would be. And so instead of the column, there's a handle, which I think provides useful functionality. The first major build step is layout. Here, I scribe lines on the piece of plastic with a scribe and a rule. Then, I take a black pen to fill in those scribed lines so I can see them on the drill press. Next, I cut down a few inches off the side of the cutting board, down to the size in the SketchUp drawing. Next, I cut off all 4 corners of the plastic cutting board, and then I take that cutting board to the sander and round those corners so that they're nice and smooth to the touch. Next, we go to the drill press. We will use the layout, done earlier, to drill and tap the 7 holes that are required for the 5/16 threaded rod. First, we'll use a combination drill countersink. Then we'll follow with a 5/16 drill. Then we'll countersink those holes so that we can tap them. I'll use a tap wrench to drive the tap, and a point in the drill chuck to center it. Now, on the drill press, we center drill with a combination drill countersink for a pilot indentation for our 5/16 drill bit, which then drills the main hole. Next, we clean up that hole's top with the countersink so that we have a good bearing surface for the tap. And when we do the tap, you will see that I back off a little bit. I reverse rotation to break chips. And that may seem silly in a plastic, but I believe even in a plastic, chips can cause deformation of the thread because of how soft the plastic is. Next, I lay out the holes for the flange that will be attached to the top plastic board for holding the cane. Now I drill the hole at the center of the pipe flange, and then I drill the holes around the periphery for the bolts that will go in and secure the pipe flange to the plastic board. I tried gluing the silicone to the HDPE plastic. That did not work, so I then moved on to mechanical fasteners. For those fasteners, I drilled 1/8 inch holes to accommodate panhead bolts. I also counterbored the holes so that the panheads could be sunk below the surface of the plastic board, so that the heads would not scrape on the floor or on the client's feet when in use. Now we're going to cut the threaded rods used in assembly. To do that, we use a double nut and some calipers to measure out the length of threaded rod we need. Then we tighten that double nut, check the measurement again, and cut at the face of those double nuts. Here it is on the horizontal bandsaw. After cutting, we will also paint the threaded rods to prevent them from rusting. However, this I did off camera. Now we can move on to the final assembly. This is done by taking 4 pieces of wood and cutting them exactly to the length required to get 6 inches between the 2 plastic boards, then clamping upon the 2 plastic boards so that we can now move on to threading the threaded rod through the threaded hole in the top plastic board. As you do this, it is important to remember to thread on the 3/8 nuts and washers that are required in the final assembly. These nuts and washers provide a great deal of stability to the entire assembly. After getting on those nuts and washers, you can continue to thread the threaded rod into the bottom threaded hole. At this point, I check the measurement from the end of the threaded rod to the surface of the plastic board. I cut the threaded rod slightly less than 6 inches, so this measurement should be around 50 thousandths of an inch. Once satisfied, tighten the nuts by hand, and then come around with a wrench and tighten 1/4 turn further. It is at this point that I recommend you attach the rubber to the plastic board. It was attached in this video earlier, however it became quite cumbersome in the final assembly to have the rubber in the way. Therefore, I suggest you attach it now, once the final assembly is done. You can also attach the bolts that hold on the pipe flange on the bottom of the top plastic board. We can now drill the hole through the pipe nipple and through the cane. This hole will allow us to fasten a pin through the pipe nipple. This will allow us to attach the base of the cane to the cane itself. I used a 1/4 inch pin, and so I drilled a 1/4 inch hole. The nice part about the pin is that it's a very secure fastener that also is easy to remove. So the whole assembly doesn't have to be the size of the cane. It can just be the step. Now I take a modeling knife and I cut a hole in the silicone rubber so that I can insert the cane shaft. Then I align the pipe nipple with the side of the step so that the pin can be assembled through the pipe nipple and through the cane shaft. Then I attach the chain from the pin to one of the bolts from the flange. Then I cut off the bolts to length. Here you can see me testing out the product. It worked very well. It was very strong in the vertical direction. However, I became concerned about side loading. As people rocked back and forth on top of the stool, I assumed that the threads, the plastic threads, would wear out, causing a lot of slop. And so what I did to address that issue was I attached guide wires going from either corner so that the horizontal forces were also braced against. Thanks for watching. Have a good day.